Hi, my name is Arve, and today we are going to learn about how to organize a process for our software development projects. So let's begin. Organizing the process. So before that, let's first define the meaning of organizing the process. So organizing the process is a critical activity that takes in everything from the management of people to the management of all products produced during the software life cycle. So, organizing the process is very important in order for us to control the risk and limit the failure that we can have during our software development. So, organizing the process also help us to manage and to create baseline or project baseline for our projects. So, organizing the process have has two different factors. We have methods and methodology. So method means a defined way of doing anything, especially in an orderly way. And methodology is defined as a system of methods. So it is very important to document the methods and the methodology in the project in order for us to understand how to organize the process. There are three widely known methodologies: the structured analysis design, and the Jackson's system development, and unified software development process. So, before we understand the advantages of these three widely known methodologies, let's look at first about the disadvantages of these three. So, the disadvantages of these three methodologies are they all lack solid formal foundations. Number two, certainly supported by common sense. And number three, they require an engineer to exercise judgment, in which we can conclude that these three methodologies requires the intervention of a system analyst and or an engineer in order for these system methodologies to work. So let's run through the structured analysis, structured design. So structured analysis design uses three major conceptual tools. We have data flow diagrams, data dictionaries, and structured English. So data flow diagrams have two types of representations. We have the standard one and the database. So database uses in indexes and methods, and the standard uses the the standard objects and similar to a flow chart. So data flow diagram used as a reminder to the reader. Data dictionary means a centralized collection of definitions of functions to or from data stores, and structured English used to describe the data transformation performed by each elementary bubble. So these three are necessary in order for us to create a well-designed structured design or structured analysis design. So here is an example of a data flow diagram. So as you can see, there are three objects here: the input device, the output device, and a file. So an input device goes through a data transformer. So in this case, a data transformer is an action in which if an input comes through it, it transforms into an output process or an output device. The file here is a factor that affects the process of an input device into a new uh, object or device called an output. So structured analysis design, another example. So here is an example of a structured diagram. So as you can see, this is the whole system in which these three are the structures of this system. So if this is the whole system, this is the main system in which these three are its components. So there are many examples for that. For example, if if we make this letter M here, the driver, components of the driver will be an input of driver license, driver IDs, addresses, and other informations, in which these types of data are are are, are belong to the drive to a driver, in which these things here is called a system. So let's then look at Jackson system development. So Jackson structured programming is a popular design method adopted in many organizations for business data processing. And while structured analysis or structured design basis system modeling on DFD, GSD is represented by mixture of descriptive approaches based on object-oriented design. So GSD also has three sequence of three stages. We have the modeling stage, the network stage, and the implementation stage. So we are going to run through it. So let's start with the modeling stage first. So in the modeling stage, entities are used which model objects in the real world and actions or events that may affect them. An entity is then defined by the actions that model events that may occur in its history. And the entity is described by a process structure diagram. So you see here, this is an example of a process structure diagram. So in here, there are three process structure diagrams. We have the A, B, and C structure diagrams, in which these three are different processes in a similar system, or in a single system. So these three involves different objects and different entities, but they belong in a single or in a same system. So in the network stage, each entity is modeled as a process, and the entire system is a network of interconnected and communicating processes described by a system specification network, or SSN. And then data stream is considered a FIFO, or first in, first out queue of messages. This means that whatever data comes through the process, it is then directly processed by the system, in which it also yields uh, first it also yields the first input into making it into first output. So another form of process connection is provided by state vectors, whereby one process may inspect the state of another process. By inspecting state vector, a process may access the history of another process, which is recorded in the form of data. So here is an example of a network stage. Here, the difference between modeling stage and network stage is that network stage has this A, or an action over here, that transforms the first entity into this entity. So P transform into Q and prime P transform into Q, which signifies that this A here contributes to the transformation of value of P and Q. So now you can see that the difference between the data flow diagram and this is that the the way that it is defined first. So data flow diagrams uses real entities also, but in Jackson stage it uses the last stage called implementation stage. So the difference is then that the implementation stage uses the processes to transform into an implementation, and the concurrent network of processes is transformed into a sequential system that is executable by a conventional machine. Now, here is the big difference between the SA/SD and the GSD, because the GSD can be used into conventional machine languages. This means that it can be used into programming languages, or I mean assembly languages, in which the structured analysis cannot. So to effect the transformation, GSD uses a technique called process inversion. So process inversion transforms a pair of communicating sequential processes into a hierarchical structure in which a program invokes a sub-program. So here is an example of the GSD. So as you can see, the GSD has the Jackson structured programming, in which this type of algorithm can be transformed into a machine language. So in the first stage, we have the processes used by the modeling stage and network stage, and after that, JSP is used in order for this modeling and network stage to be uh, invoked into a implementation, in which here are the implementation codes that can be used into a conventional machine. So the another system methodologies is called the unified software development. So unified software development uses the unified modeling language throughout the software lifecycle. So UML provides specific notations to specify, analyze, visualize, construct, and document the artifacts that are developed in the lifecycle of a software system. So UML has different types of diagrams in which it can represent its object into real life entities. Also the same with Jackson, but the difference is that you can the system analyst or the engineer can visualize it and analyze it much more efficient than the Jackson system development. So UP casts the development of an object-oriented system into an iterative and incremental process model. And UP, or the Unified Software Development, also uses each cycle in turn to divide a sequence of 4 phases. So each phase terminates in a milestone that may be used for project control. So this is one of the advantages of UML system, in which every milestone that it achieves, it creates a project baseline in which we will discuss later on. So this milestone can be used for project control, as such that the UML can predict what's going to happen on the next processes of the software development lifecycle. So here's the unified software development process. So in cycle 1, there is always a product release, cycle 2, product release, and so on and so forth until its death or its completion. So there are four rather um, important cycles, in which that each cycle must have its priorities. So in the first cycle, the priority must be inception. Second cycle is elaboration. Third, construction, and fourth, transition. So this is not this these cycles does not mean that it must really it must really follow what's in this table here, but it only serves as a guide in which this four is very important to be used in order for the unified software development process to work. So inception, highly valued, or means it values feasibility study. So inception here in inceptions, the software processes are defined and whether it is feasible or not. So in the next cycle, elaboration is greatly valued. So cases that are assumed to become part of the current release are specified in detail and the software architecture is developed and specified. In the next cycle, construction is valued. So it means that the product is built by enriching the architecture baseline and developing the testing code. So next then is transition, in which early adapters tries the product and provides report on possible defects and deficiencies. So here are the table in which cycles or iterations here are shown. So in requirements or in creating requirements, right? If you want to create a requirements analysis document, here is a table that shows the here is a table that shows on how you will value each processes on each stages. For the requirement stage, the inception and elaboration is highly valued, and for analysis, the um, the elaboration and construction process is valued. So in design, construction and elaboration is valued. Implementation, there is a highly or construction is very highly valued, and in testing, everything is then valued. So as you can see here, inception, elaboration, and construction and transition are very important in software development process because it helps the business analyst to analyze the workflows and know what to know how to to how to make import or how to give importance on each life cycles. So let's now proceed to configuration management. So configuration management is very important, especially for system analysts. So let's say, for example, that a leader does not have any types of rules. It does not set any rules for his organization. So what do you think will happen to that? So you will know, you can predict already that this organization is doomed to failure, or it has a higher risk of failing. So same with software development process, it is very important to have a configuration management or set of rules in order for the software development to finish without or with less failures. So there may be hundreds or thousands of components in a collections. So how do we keep all this under control in order to avoid it being lost in an unstructured collection? So that is why configuration management is created. So configuration management is the discipline of coordinating software development and controlling the change and evolution of software products and components. So configuration then of a product identifies its product components and its specific versions of the components. So configuration management is very similar to policies, in which every type of every set of rules are defined in order for the users and for the system analysts to review it and to understand the system further. So, in order to handle all products generated during the software process, configuration management policies are needed. And then, project baseline is a central repository of reviewed and approved artifacts that represents a given stable point in the overall system development. So, as I have mentioned earlier, right? Project baseline is also called a milestone in which every every product that has its own system, its own working system should be highly or should be backed up before proceeding into another system for us to avoid any conflicts. For example, if the project along the way the project became the project was destroyed, or what the project was um, the system were misconfigured by someone. So project baseline provides a solutions for that, because whenever you have a given stable point, you can just go back to the previous state of the project or the system, in which you can just start it from that, instead of going to the starting point of the system development process. So the baseline serves as a shared database associated with the project. Derived version is a term used to describe components of the baseline that are related to one another. So just look at the example of, for example, just look at the example of Windows versions. So as you can see, as you have known, um, Windows has this version, Microsoft version 8, in which the company retracted its Windows 8 version because it finds a lot of bugs along its software development process. So instead of continuing the the Windows version, the management concludes to create another version based from Windows 7. So this version is then called Windows 10. So Windows 10 has somehow similar policies with Windows 8 and 7, but it has more stable um, management control policies and other drivers that it gets from the Windows version 7. So I think that's all for today, and thank you for listening to my reporting or discussion.